Hello, we'll start in a minute. Okay, this is our last formal lecture. We have 2 more weeks of class to go, so the rest of the time on Mondays will be office hours from 3 to 5. And this is giving some discussion about an alternative process. You know, we've been working with Agile Scrum, but we've talked about different software development models like Waterfall. This is a software development model that was developed at the Software Engineering Institute at Carnegie Mellon. Embry-Riddle was partnered with them for a number of years, up till about 8 or 9 years ago, probably. So a lot of early work in software engineering was done through them and by people in our faculty, like Dr. Thomas Hilburn, Dr. Masoud Tahid-Nejad, and Dr. David Glutch. Several of those have retired. As some of you may know, Dr. Tahid-Nejad still hanging in there. This one can be very documentation intensive, and it's to give you an indication of the lightness of the documentation of the Agile Scrum approach. I see that there are people out there trying to marry the 2 processes together to get PSP and Agile to work together. So I think I included a link in the module discussion page for that. Also, this is actually part of a pair of techniques that work together. So PSP is personal software process, and the idea is you learn PSP as an individual, and then you do TSP, which is team software process, and you take what you learn as an individual and you apply it to a team setting. They're very similar, though, in their work. So, process, series of steps taken in order to achieve a particular end. We all have processes. We all have processes to try to just get basically anything done. And some are very informal. How do you know what's for dinner tonight? How do you make that happen? You know, you have an informal grocery buying / cooking / order out process. If you stop and think about what your processes are for schoolwork, it can be very helpful. And so one of the things that I hope you get out of this course is just an awareness that process exists and an awareness that processes can be looked at and improved. So what we talked about last week were software development models. These are the frameworks, but the frameworks then are adapted by an individual person or individual organizations, and they become specific processes. You guys know this stuff. If you want to add a class, there's a process at every riddle, there's a process for that. If you want to drop a class, there's a process for that. If you want to change your major, there's a process for that. Right? There's processes for all these little things. As a rule, you could argue that most processes that you find in the real world can be mapped to different frameworks. And so sometimes there's a little bit of this and a little bit of that kind of thing going on, or this seemed part of the process appears to belong to waterfall, and this part of the process appears to belong to, you know, V development or something like that, or spiral development. The process frameworks, you know, you can go to back to last week's lecture and look at. And then the individual processes, you tend to have to look at a specific organization and find out what they're doing. But then we get these questions. Okay, great, we got a process. Is the process any good? Is the process actually making us worse at our job? Is the process making us do a lot of work that doesn't actually contribute directly to the product or to real productivity? And these are questions that should be asked. And so even as a student, you can ask yourself, you know, what's my process for studying for a test? What's my process for getting homework done? What's my process for planning how I'm going to graduate and get out of this place? I advise a lot of students, and when students first come to me, it is shocking to me, you know, they're all, I want to take this class and this class next semester. And then I'm like, okay, why? Why? How does that help your plan to get out? And they tend not to have a plan. So I generally say, go away and make a plan, and then we'll talk advisement. But that's really lack of process, right? All they know is they want to take some classes, but it may be that if they're taking the wrong classes at the wrong time, they may extend their graduation by a semester, which is clearly not a desirable thing. And it would happen because of lack of process. So being aware that processes exist, being aware of what your specific processes are, and being able to measure, assess, or at least reflect on, even if it's informally, what your processes are, is a positive thing. Makes you a better student today, makes you a better employee in the future. People study this, people study everything. Carnegie Mellon developed the capability maturity model integration. I think it's hyphen integration. Capability maturity model is the typical word, CMMI. And this is a way that you can try to categorize process maturity. And there's, oh gosh, lots and lots and lots of papers written on this stuff, and lots of not guidebooks per se, but papers that talk about, you know, what do different processes look like in their different stages of maturity. And they basically define these 5 levels. So initial is no process. We have no process. Everything is ad hoc. The organizational environment doesn't impose or any kind of a process. You know, it doesn't really support the creation of processes or the maintenance of processes. You may work for a place, or you may have seen this, where nothing is written down. It's always, how do you know how to do it this way? Well, that's how we always do it. How did you learn that? Well, the person before me taught me. Okay, that's generally a sign that the processes are ad hoc. It's definitely a sign that the organization isn't supporting the processes, because there's no way to distribute the knowledge of the process other than word of mouth, which is, you know, terribly, notoriously ineffective. Then the next, which is managed. Now you've got projects are planned, you've got procedures, you actually have your outcomes monitored, you're looking at a little bit of reflection. After that comes defined. Now you've got actually a set of standards. No, okay, now these things are written down. The processes are well defined because they're written down. If you want to find out what the processes are, you should have a place to go to find out what the processes are. You know, Embry-Riddle has a whole bunch of processes written down. We have policies. The APs are academic policies. And they basically tell us the rules for what happens in the academic world. And then we have APPMs, which are human resource kind of related policies. And we have a faculty handbook that tells us what our roles and responsibilities as faculty are. And in addition, it lays out a lot of process stuff for, you know, how do I go through and get, or what's available to me for, you know, if I want to go on a sabbatical, or if I want to apply for a promotion. At each college, we have processes written down for how to do yearly evaluations, how to do this, how to do that. So written down. The next is quantitatively managed. Now, not only are they written down, but you have established a set of goals, you've established a set of metrics, and you are periodically looking at these metrics and then matching them up against the goals. And there would be a mechanism in place to modify the process at that point in order to hopefully improve them. And then of course, the last is optimizing, where actually it's built into the system. Now, all this other stuff is cooked into the system, where you have not just processes that are written down, not just where you're measuring yourself against some kind of set of standards, but where you're actively working to continuously optimize the process. So there's a meta process there in which you are working to optimize the process. Now, informally, as an individual, you can be on that optimizing level fairly simply because there's not going to be a whole lot of requirement that you write everything down about your processes. But as a student now, as an employee later, you may want to do this, you know, optimizing trick where you're looking, you know, thinking hard or looking at your processes and describing a set of measurements for yourself. And then working to modify your process in areas where you're not happy with it. You know, when you get a really good grade on a test, maybe you should reflect on what did you do right? What caused that result? Was it luck? Was it just you liked the material, so it came naturally to you? Or was it you studied really hard, you know, you worked in a group, whatever. But whatever it is, try to identify it so you can do it again. And obviously, if something, you know, you got a really bad grade on a test or on a homework or a report or whatever, same trick. What happened differently that you didn't like that you should change? So having said that, we will pull this into the back into the software engineering realm. And talk about what the PSP specifically asks for you to do. Now, this is not required in this course. We used to teach PSP and TSP in this course and in capstone design. We stopped doing that 6 or 7 years ago because Agile Scrum was very clearly becoming rampantly popular in the real world. So we switched over to the Agile Scrum method. But this is still out there. And there are aspects of it that I find valuable. There are aspects of it that I believe to be unworkable in a real world situation, or at least if you were to follow it rigidly, it definitely goes against the agile principles that working software is more important than documentation. So, you know, we'll start looking at some of the documentation in a little bit. Okay, so the idea here is there is such a thing as individual process. There's an individual process in terms of how you create software. You know, think about how you create software. And then this PSP is a specific way for you as an individual to create software. And I encourage you to take some aspects of this and do maybe not the full PSP process, but some aspects of it. Do some partial PSP stuff while you're building code this semester. And the reason is you do get good information in terms of your productivity rates, and you do get good information in terms of your error rates. And those are really critical to know. Okay, so what is this? It's a set of methods, forms, and scripts. And the main thing here are the forms and the scripts. So you have scripts that tell you how to do things, particularly milestone events. Like we have in the Agile Scrum world, think about the meetings you have. You have your sprint planning meeting, you have a sprint review, and you have a sprint retrospective. Now, how do you know what to do in a sprint planning meeting? You know, instructor says, okay, thou shalt have a sprint planning meeting. How do you know what's supposed to happen in a sprint planning meeting?
The Scrum Guide.
The Scrum Guide, right. And what does the Scrum Guide give you in terms of what should happen in the sprint planning meeting? In a nutshell.
A process.
Right. And specifically, doesn't it list, here's, I don't know, 5 things. At the end of this meeting, these 5 things are complete. Right, so a very clear set of what's supposed to be the outcome of that meeting. Other than that, it doesn't really tell you that much about how to conduct that meeting. It just says, when you're done with this meeting, these things are done. That's the goal of the meeting. And the same thing is true for the scrums and for the sprint review and the retrospective. So the Agile process is a little more flexible in terms of how you get things done. It just says, here's what you should have at the end of the meeting. Now here, we'll see scripts later. These scripts are a lot more prescriptive. They have, here's a real script, step-by-step stuff. And the forms are forms for logging data so that you can keep track of your productivity and error rates. And then the methods are, okay, great. You've got these forms and you've got these scripts. Now, what do you do with it? And so the methods are about how do you use those things to try to improve the process. And it says here, after continuous use, the process allows for a scientific foundation for growth and improvement. And that is absolutely true. This thing has been validated in real world situations. And so there's some good stuff there. The biggest critique of this, it is documentation heavy. And if you follow it religiously, in my opinion, it is very, you'll see it's very documentation heavy. That's why I say you may not want to do a full PSP for yourself for the rest of the semester, but take some aspects of it, think through these things. Okay. Let's talk about this. Any stable, mature process allows you to estimate and plan your work, meet your commitments, resist unreasonable commitment pressures, understand your current performance, be better equipped to improve your capability. Okay. Now let's talk about a couple of those things. Estimate and plan your work. Why do you care? Who cares, right? Why do you care if you can estimate and plan your work?
For me, if I don't plan out my week ahead of time, I won't get anything done.
Okay. I do that at the daily level. I can only think one day ahead. So, but same trick. If I don't plan out my day, nothing gets done. How about in a business environment? Someone comes up to you and says, I want you to build this software. How much is it going to cost me? How do you come up with that cost? Here's how it's done. It's very straightforward. You say, okay, that's going to take us 5 engineers and 1 manager. And it's going to take them 6 months, 40 hours a week. So now we've got, gosh, 40 times 4. 40 times 4 is 160. Let's call it 200 hours times 5 is 1,000. Let's call it 1,200 hours of work. We pay these people at $50 an hour. So what's that? $70,000. And then we always double it. So we're going to charge you $140,000. But notice what the core of that cost was: people hours. People hours and rate of pay. And then typically a company will roughly double that. So whatever your company is paying you, they're charging you roughly double to the customer. Why? Because they're paying to keep the lights on, to give you a desk, to give you resources, to give you, coffee room, whatever. And to pay all the people who help you out that aren't directly charging to the project. So clearly being estimate what you think future work will be is critical to making a profit or not. You get locked into that $140,000 project, and then it turns out that it cost you $160,000 to make the product. You've just lost money. Similarly, helps you meet your commitments because, number one, you estimated better to begin with, and number two, you're planning your work along the way. You're resisting unreasonable commitment pressures because you have a fixed process and it's kind of airtight. It's hard for stuff to leak in. You understand your current performance because you're tracking it. Oh gosh, over the last 6 months, my productivity went up. I used to do 20 lines of code an hour, and now I do 22. I used to create 100 lines of code in an 8-hour day, and now I create 110. And you're better equipped to improve your capability because you're becoming aware of what your capability is and where your issues are that need to be resolved. Now, let's take those same five things and compare them with what you're learning with Agile Scrum. How does Agile Scrum help you estimate and plan your work?
Well, I guess the backlog keeps track of everything that you have left to do. So, whenever you update the burn down, you can see how much you have left.
Right. So what Agile Scrum actually does, and basically all of these are going to come down to the same thing. Agile Scrum, the first time you encounter it, does nothing to help you estimate your work. It does help you plan. Isn't that the whole backlog? Let's take these out of the backlog and into the current sprint. So we're planning what we're doing, but we're not planning it for the whole project. We're planning what's going to happen this sprint. So it is helping you plan on a short term, right? Everything on Agile Scrum is more about the short term. And then, as you said, you can look at your performance during each sprint and say, man, I really underestimated how much effort all these tasks were going to take. So in between the sprints, remember, during a sprint, everything's frozen, but in between the sprint, you can say, oh, maybe we need to go back and update all of our estimates based on what we've learned this past sprint. So that's good. But the estimation, here's the bottom line. The estimation of what an entire project is going to take from front to back, the only way you're going to learn how to do that is to go through multiple iterations of projects. Now, you may already have that for, say, a homework assignment. If someone gives you a homework assignment, depending on the class, do you immediately have an estimate of how long that homework assignment will take? And if not, do you ever actually try to get a hard number for that? Or is it just, oh, I'll do it later, or I'll do it right away? What's your method?
Honestly, it's just do it later.
Uh-huh. So how would things be different if you get, because you're getting homework assignments for left and right, where all of us professors are hitting you from all sides with these things. And so do you ever sit down and say, okay, I really quickly looked at this one and this one and this one and this one, and so I know that this is a 1 hour homework and this is a 3 hour homework, and you know what I'm saying? And then actually think about, okay, I've got 40 hours this week or 60 hours this week to work. Where am I going to fit it all? As a student, I know I really never did that. I was not aware of the idea of process as an undergrad. But I think, man, life would have been a lot better had I been aware of process. Although I did have an intuitive understanding. I think you all know this. If you're halfway through a semester, you get a feel, you have a gut feel for that professor and for that course, what an average homework assignment is going to take. Is that a fair statement?
Yeah, I would say so.
I mean, I know like I could take Calc 1, Calc 2, and they give you a set of problems. And after a while, it's like, okay, I know how long this is going to take. And then, when I took thermo, it was like, man, each one of these homeworks I know is a long homework, because back then we didn't have computer tools. We had to do iterative solving through table lookup in the book. And, every homework was a 3 hour homework. So you get to learn that. Now, what would happen if you consciously, instead of just gut feel, went through that and started to think about, that's due Friday, but it's a 3 hour 3 hour task. I better break it up between Wednesday and Thursday or something like that. So anyway, you get to plan through iteration. That's really the way how a real project is going to take. You do it over and over and over again, and usually you start out in a business setting where you're not making those decisions. You're working on the projects, and as you work on the projects, you learn. Okay, now I know if customer comes to us and wants us to build product X, we know it takes about this much effort to do X. All right, meeting your commitments. Same trick. If you've estimated and planned properly, you're going to meet your commitments. How does Agile help you meet your commitments as opposed to PSP? Oh, stuff's happening in chat and I'm ignoring it. Let me try to put that up. Okay. How does Agile help you meet your commitments?
In Agile, you commit to specific, like it's built into the process where you commit to specific user stories every sprint.
Right. So you guys have created your own user stories. Number one, you're self-committing because your team is creating your own user stories, and then the team gets to choose, right, what's going to happen in each sprint and how it happens. So that's not an external entity saying this is what's going to happen. The team has to buy in, and it's buying in a short cycle, 2 weeks. So in that short cycle, you're making yourself responsible only for some small snippet, well-defined task. Along the way with that, when you do your sprint planning, the idea that when you have a user story, you have the whole team has to agree on what it means for that user story to be completed. That helps you meet your commitment, because when you say, look, it's done, everybody says, well, it meets the user, it meets our description of what done looks like, therefore we all agree. And also, I'm encouraging you guys, when you're getting a specific software task, to come up with a specific requirement and test case, or ideally you would do test cases for these things. And again, that helps you meet your commitment because it's a clearly defined boundary. Look, I wrote this software, it passed the test cases that we agreed upon. I am done. That is not an opinion, that's an objective fact. I'm done. How does Agile handle unreasonable commitment pressures? This is a tricky one. Let's back it up to the philosophical level. Structured things like PSP and waterfall try to manage change one way, and Agile tries to manage change another way. What's the difference in the two ways? Be brave. Here's Agile is more open. Exactly, Brandon. So here's the way I view it. Structured systems try to constrain change. They try not to allow change. And Agile tries to say, you know what, change is going to happen anyway. So let's have a process that will adapt and adopt. Now, the word unreasonable is in there. There's still unreasonable change that gets resisted by both sides. And the way Agile does it, remember, if you're truly doing Agile to the nth degree, you are interfacing with your customer often, right? Regular cycles. Ideally, you would have a customer rep embedded in your team. And so you get this notion of unreasonable commitment pressures. Well, when does a commitment pressure become unreasonable? When you literally can't do it in some period of time, or they won't pay you. Well, if you're working with the customer constantly, you're also constantly negotiating. And so the unreasonable commitment pressures become changes in the commitment, but ideally the unreasonable part goes away because you're constantly interacting and negotiating with the customer. And you're saying, yeah, we're okay if you want to change some stuff. You know, we're going to charge you for it. That's okay. But we are okay with changes to the design, you know, to the product. Understand your current performance. How does Agile do that? I think we've covered that one already, but let's repeat it. Oh, actually, there's more stuff there. So what I noticed is after sprint 1 and sprint 2, almost every team had settled down into a rhythm and kind of gelled as a team. You know, that's team maturity. How did they do that? Well, they did that because they've gone through a couple sprints. You got to see what it was like to go through the process, so you got more familiar with the process. But you also have the burn down charts where you're constantly looking at what effort you have left, and you know if you're ahead or behind schedule. So you understand your current performance in terms of the planned schedule versus the actual, or the planned amount of work left versus the actual. And also, what's that whole thing with the sprint retrospective? You're supposed to, as a team, review the team dynamics and the team processes and the logistics of trying to communicate. And that helps you understand and immediately, hopefully, improve the performance at the team level. So Agile has these things. PSP has them too. Agile has them. They just look a little different. And be better equipped to improve your capability. Now, the reason that PSP is going to say that, you'll see, is because you have hard data as to your capabilities and productivity. And so, you know, there's hard data staring you in the face, and you can look at where your deficiencies are and try to say, okay, I need to work on that. with Agile, would you say that that Agile process, going through the Agile process, not that it has improved your capability to date, but it's given you that you're better equipped to improve your capability in the future? Would you say that that's a true statement, maybe true statement, completely wrong? This is where face-to-face better, because it's usually easier to draw answers out of you guys. I think with Agile, unless you're doing some actual tracking, again, along the lines of PSP, it may be harder for you to be, quote, better equipped to improve your capability. You are better because you have experience. You know, how do you get good at being a writer? Write every day. How do you get good at designing software? Design software every day. So you do get better. Your capability is improving through experience. But how about your knowledge of what you need to do to make yourself better? I'm not sure that Agile really has an embedded, obvious quality fixed to that. Other than your experience maybe saying, man, I didn't do that so well, and I need to figure out how to do that better. But it's not a data-driven process, obviously, whereas PSP is. All right, so the title of that was Any Stable, Mature Process, which means, yeah, PSP should do this. Agile should do this too. Waterfall should do this too. And I should say a process based on waterfall should do this too. Okay, now remember the Agile principles. Working software is more important, most important. More working product is more important than documentation. Teams and communication are more important than fixed processes. Those kinds of things. The PSP principles are a little different. They're talking about the basics of product quality first, and basically, you know, it's the weakest link in the chain theory, right? The quality of software is the quality of its worst component. Why? Because you take these components, you put them together into a system, and if one component's constantly failing, then the whole system is failing. The quality is governed by the individual, governed by the quality process, and the key to quality is the individual developer skill, commitment, personal process discipline. Now, would you say that all four of those things would also apply to the Agile world? Yeah, I think they do. The reason I'm framing this way, by the way, is because you guys have experience with Agile now. So here we're talking about PSP, and it'd be great. I can say, okay, here's the Agile process, and then here's the PSP process. But you know, we can go to the meta level and say, okay, now let's take these two processes and bounce them off against each other and compare them. And notice, by the way, at the meta level, they are solving the same problems and they are saying the same things. They've come up with different solutions to those things. Individual quality uses of a defined and structured process improves efficiency. Now that's the key here, is defined and structured. Would you say that Agile is defined? And would you say it's structured? That's a tougher one, right? I think it has a lot of structure, and part of its structure is that individuals have more encouragement, let's say, to adapt it to their unique things. So the term structured there is going to be used a little bit differently between the two. PSP, when they say structured, and you'll see when we start looking at the scripts and the forms, they mean structured. Everybody does the same thing. And what the agile processes is more about is, no, each team is going to be unique, and each team gets to develop their own version of the thing. But there is structure to the overall agile framework for sure, right? The idea of sprints, the idea of a product owner, a scrum master with very, very specific rules as to what they can and cannot do. There is structure there, but then in practice, it can be a little more flexible. Whereas in the PSP, you'll see in practice, it's still pretty rigid. Am I going to go through I'm just going to fly through these. So then, you can read these right while I'm babbling. Properly designed personal processes, individual processes, conveniently, I got to get this out of my, conveniently fit the individual skills. And that's really good. But that ironically is one of the biggest criticisms of PSP is it's not convenient. There's too much data logging. There's too much record keeping is the biggest critique of this. For professionals to be comfortable with a defined process, they must be involved with it and agree with its definition. That is absolutely true. If you do not have buy-in from the people that are doing the work, then they will not do the work the way the process says. And we know this. I mean, I knew this in industry. I experienced this a lot in industry. And I experience it now. If I don't get buy-in from students to do something, perfect example, CS225. I have students do you've all been through it, the P2 deliverable where they're doing their product description, problem description, the P3 deliverable where they're doing their design, prior to doing any coding. And the students in that class have two issues. One is that, they're still young and it's tough for them to have the vision of how they're going to do this ahead of time. So it's tough for them to do both the product description and the design. That's just lack of experience. But also, I don't get much buy-in for that. I think the mindset of most of the CS225 students at the beginning and mid-semester is, I'm just going to start coding and it's all going to work out fine. And then by the end of the semester, when there's a lot of trouble, then I get to hopefully convince them of the value of the planning that you should put in ahead of the coding, hopefully. And hopefully by now you guys are like religious zealots running around telling people to plan before you code, hopefully. So when next semester, when someone in this class is asking you for advice, or if someone in CS225 is asking you for advice, I hope your advice is, do all your planning before you start doing your coding. I hope. That's an illusion I have. It comforts me. Professionals' personal skills and abilities evolve, so should their personal processes. That's absolutely true. When you are newer at something, you tend to be, the processes should be a little bit more constrained so that the processes help you along. And as you grow, then you may have more control over how you, the actual process that you use. And continue a process improvement handled by rapid and explicit feedback. Hopefully we all believe this. Hopefully we believe this. Now the trick to this is, what is that rapid and explicit feedback? What is it? You're getting it in the agile world with the sprints. If you're doing a proper sprint review and a proper sprint retrospective, the agile people says, yeah, you should do this rapid and explicit feedback, but don't let it take over your life. You're going to have a sprint review time boxed at 1 hour. You're going to have a sprint retrospective time boxed at 1 hour. And that's it. Whereas PSP, as you'll see, the data logging that they want you to do is far more than you would normally do in another process. Okay, we've already talked about this. In order to understand your work, in order to plan and estimate, you have to understand your work, and you have to understand your own specific productivity. You know, when I was in industry and in working for McDonnell Douglas in St. Louis, and they would get a new contract and they would bid on the contract. And they, you know, the contracts people would come to my desk and say, okay, for this contract, you have to do these, you know, 25 tasks. Tell me how many hours, excuse me, how many hours for each task. And I would tell them the hours for each task. How did I know? Because I'd done it before. So now I'm going on my experience to tell them how many hours it was going to take. In order to make this happen, PSB, as I said, excuse me, provides scripts. Now, scripts are for the process events for the major meetings, and then worksheets for you to record data with, and then processes to use that data to do your future estimate and planning. Okay, why is this actually useful? Correlation of product size with development time is actually good for individuals, not necessarily good for teams or organizations. Graphically, it looks like this. So if you look at your top down, your planning, design review, code review, compile, test, postmortem, top down, that's kind of a waterfall model of development. And then the shaded blue would be the PSP overlaid on that. So you've got your overall development process, and then you have the PSP on top of it, which is the data recording, the scripts that help you manage meetings, and the processes by which you turn that stuff into information that's helpful for the next project. So you have scripts for your plannings, you know, your code review, probably should have been for design review too, for the postmortem. You have logs for all of your data, for all of your work, and then you can try to summarize all that and figure out, okay, if we have to do this kind of a project again, what's it going to take? Scripts, and I'm going to pull one up here in a minute. Have three basic parts: the entry criteria, the instructions and checklists, and the exit criteria. And I gave you all these, they're all zipped up. So if we look at the planning script, it's got entry criteria. These things have to be done before you're allowed to start the meeting. I guess planning, in this case, planning may be more than one meeting, but you know, you have to have a problem description, you have to have a project plan summary form, you have a time recording log. That's the entry criteria that gets you in. Then you do these things. And then you're not allowed to say you're done with planning until you have these exit criteria: the documented requirement statement, the completed project plan summary, the completed time recording log. The time recording log is actually to record how long it took you, I believe, for the planning to occur. Because the planning may not be just one meeting, right? It might be, you know, think about that. They're saying that you have to have a documents requirement statement before you can say you're done with planning. Note the inherent waterfall nature of that, right? They're assuming all the requirements. So what I like about this is it's very clear about what you need before you can say you start, and what you get when you're done. I like that. What is not going to be so great for some of these is the degree of granularity that they go down to into the different processes. For example, postmortem script. You need the problem, you know, all these things, right? So you've got this, and then this defects injected, defects removed in time. there's a lot of data logging associated with that. The defect recording log is not trivial. Exit criteria, fully tested program. What does that mean, by the way? We don't know what that means, right? You cannot fully test a program. You can just test it to the degree that you think it's satisfactorily tested. Completed project summary form, defect in time recording logs. That's all your future data that you get to base future estimates on. So those are the scripts. They look like that. And like I said, I've given you, I've zipped all these up and included them on them. Okay. Scripts aren't bad. Now, but again, notice the difference. Here they give you a script, which is the entry criteria, exit criteria. In the Agile world, what did we say? For the way they told you what was going to happen in the meeting, it was basically, here's what you will have when you are done with the meeting. And they didn't go into a lot of detail about how you make that happen. That's up to the teams to determine how they want to make that happen. Okay, measurement, we get three types of measure: effort, which is time; size, lines of code; and defects, which is going to be your quality measure. A defect is any error. It could be a typo in a comment statement. It could be a fatal error upon execution. It could be a syntax error that causes a compilation error. It's kind of, I think the term is a little rubbery in the absolute sense, because as a person who's typing, if I'm just typing along and I notice a typo right away and I fix it, was that a defect or not? I think you really want to wait till you, quote, are done with a piece of code and you're showing it to another group, having it reviewed, or having another person look at it while it's executing, before you may want to call these things defects. Time recording log. We'll look up all these: the defect recording log and the time recording log, and then the size. I'm not sure that I have a log for size, which is weird. I think I should have. All right, so let me take a look. If we look at the logs here, the time recording log, you have put down your date, your start time, your stop time, your interrupted times, what phase you're in, and what comments. Delta time, I apologize, I can't remember what that is off the top of my head. It's obviously a difference, but I can't remember what the difference is. It might be the time you went over from your plan. I'm not sure, over or under from your plan. But look at that. Now let me ask you this: when you sit down to code for this class, you go through your sprint meeting, you go through your Scrum, you received a task. Your job is to fill out 3 methods in a class, and you're like, great, I'm going to go code this. Do you do this?
Nope.
No. And that's what I mean by data heavy. It's really tough to have the commitment to do this every time you sit down to write code. Oh, and by the way, it's not just about writing code. It might be creating a UML. It might be creating requirements, right? Anytime you do work. So I mentioned that I think the biggest criticism of PSP and TSP is the amount of data that you have to track. And this is an example of that. It requires a tremendous amount of discipline. Now, having said that, not a bad idea for you to have a gut feel for your own productivity measures. It doesn't mean you have to do this kind of a tracking, but it's not a bad idea for you to say, I know at the end of the day, to me, the 2 most important measures are, I know roughly how many lines of code I can produce in a day, and I know roughly what my defect rate, what my errors are. And here's the defect recording log. Same trick, date. You give every defect a number. You start with number 1 and you go to number 2 and number 3. It's type, the type of the defect. Was it a syntax error? Was it a logic error? There's a whole bunch of types that PSP does. When was it injected? When was it removed? How long did it take to fix? And I have to look at fixed defect again. And then a description of what the defect was. And so for everyone, let's see. There's your types: documentation, syntax, build package. These are your assignment interface. These are going to be, where it was injected. Data, function, system, environment. And again, think about it. When you find an error in your code, how do you find it? What do you do about it? When do you find it? What's your process? Here's what I do. I compile, or I type a little bit of code, and I try not to type more than like 10 lines of code. I do the simplest small unit that I can. I save and I compile and I run. And I typically will find I have typos, typically. And then I'll do that again. One small thing, one method, even if it's like 3 lines, one method. Save, compile, run, save, compile. That's my process when I'm writing software. Not that I get to do it that often. The other part of my process is just constantly cussing up a blue streak. So my wife's like, "Oh, you're coding again." I can hear you. That's my process. Now, because I'm doing this really small save, compile, run, save, compile, run, save, compile, run, and I'm fixing all these typos as I go, I'm not stopping to do this defect recording. I'm not sure if I would call that a defect per se. I don't know when you should call things a defect in that informal setting. But it is good for me to know, oh, okay, for a simple piece of code, if it's very straightforward, I've already got all of my plans done, I know what I'm going to do, it is good for me to know, okay, this thing, before I build it, I expect it to be a class with 100 lines of code, and I can generally build 100 lines of code in, I don't know, 2 hours. If I've done my planning properly, or 3 hours, something like that. Now, that's good to know. But I definitely do not do this kind of a recording. I don't even track my all of my compiler errors. Maybe I should write down, just that I had them, in the compilation phase. I had one, make a check mark. And that way I would have a good sense of my own error rate. I think that kind of problem, and then when you're executing, really when you get to testing is when you're going to find defects of note, meaning it was probably a lot more effort to go back and fix it. I don't know, what's y'all's process? What do you do? How do you code? No takers? Compile and run as often as yeah, that's again, and I encourage, I'm a very bad planner. Yeah. So yeah, usually the software I'm doing is small enough and ad hoc enough where I don't spend a lot of time planning. So that's a badness on my part, only because again, I don't get a chance to do real programming. But when I do have anything that's beyond trivial, I will make a plan, lay out my class. I tend to do object-oriented, lay out my classes, come up with a rough UML, and then work from there. And I work from the UML. I was joking with students in CS225 a few semesters ago, because we're at this part of the semester where everyone's working on their projects, and everyone's sitting there type. Not a single UML in sight. I'm like, how do you know what you're typing? Why did you even bother making that thing? That's your plan, right? That's your design. And now you're going to type without looking at your design like you can do it from memory. No, that's not good. Elik, yeah, so when you have something that's not trivial, plan it out beforehand, right? Now, here's what I will do. Whenever I do a GUI, I will definitely take some paper, draw it out, and then tag what I want to name the different GUI elements. I'll do that. When I'm making even an Excel spreadsheet, I'll draw it out first, and or so that I can lay out, okay, how many rows and columns on this thing, that kind of stuff, and draw it out first before I organize the spreadsheet. So there is some planning that goes on. But I do not do this defect recording. I think it's a good idea, like I said, for you to have a general idea. The time log, I don't know why I don't have it here. I've got one somewhere I need to dig up. I'm going to blame Dr. Oshoa for that. I'm sorry, not the time log, the size log. Lines of code. Now, here's what's odd about the lines of code. It's not just, you're not just logging size. Oh, okay, we started with 100 lines of, we started with 0, code, now I've got 100. Code, now I've got 150. You do all these categories. You take the base, let's say you have 100, you added 20, you modified 5 existing lines of code, you deleted 6 lines of code, and then you do the new and change. So it's not just, it's literally you're tracking every line of code. What have you done with it? Now talk about discipline. That's really tough. I know you guys, are when you're trying to fix a problem in code, or when you're trying to add to code, and it's just like wild west out there, right? Type. I'll have students online when we're talking about their code, we're looking at their code, and I'll say, well, you should probably try to do this or that, that, and they start typing, and I'm like, no, don't do it on the fly, and don't break your code now, because we still need to look at it, think about it, and then come up with a planned solution and then fix it. Well, with that mindset of I'm just going to start changing my code, can you imagine trying to keep track of, this is how many lines of code I had to begin with, this is how many I added, this is how many I modified, this is how many I deleted? It's a lot of work. And then the defects, as we said, we've already gone through these. So we have the defect log sheet. Now, it's focused on the code. I mean, I think I focused my discussion on code. And I think when we think of defects, we do focus on code. But notice what's down here, incorrect design. So you can have a failure in your code because the design was wrong, and incorrect requirements. Talk about going back, right? Why is this code not doing what the customer wanted? Oh, because we actually had a wrong requirement or a wrong requirement specification. That can happen, right? That can happen. As we all know, hopefully you're learning, writing requirements and requirement specifications in particular is a tricky business. And being able to get that right is tough. And I don't care how many times I look at you guys as requirements, I'm still like, man, they could be worded better. I mean, even after I've reworded them and you guys incorporate my changes and I look at it again, I'm like, still not there. It's tough. It's tough. I'm not saying that across the board. Obviously, some of the requirements are where they need to be. But when I look at your requirements, expect for me to try to wordsmith them a little bit and don't be insulted, right? It's just a matter of, it always seems like there's a slightly better phrasing that can be used. It can't be cheated as well. Okay, then when again, you saw on the log sheet, where was that defect injected? So the reason they do that is because then when they're planning in the future, they can say, okay, we are going to do, you know, we expect, right? You start to come up with expectations. We expect that in the requirements phase, we're going to accidentally inject this many defects. We expect that in design phase, we're going to inject these defects. And you can try to plan for those, maybe by having more reviews, maybe by having some other, you know, modify your process to try to remove those, or maybe maybe you can just say, okay, we're going to accept that we're not going to find those defects till later. You can also do interesting things like, statistically speaking, this should be 100,000 lines of code. Statistically speaking, in terms of just the code itself, we should find 600 errors. We've only found 200. So either we're really good or there's 400 more out there. You get a sense of what to expect. Right? This also you may find, gosh, if we found a whole bunch of errors in the code, but really they were injected in the planning phase, what does that tell you? It means that we're not doing our planning right. And we need to modify how we plan. You know, or, you know, in the design phase. What does that mean? It means we're really lousy designers. And so we need to figure out how to get better at the design phase. So it does help you nail down what part of the process your company or your team or you as an individual needs to improve. Like a lot of logging, a lot of data. And then you start to look for things like what's your, you know, defect density, you know, number of defects per lines of code, development time ratios, you know, lines of code to time, lines of code that have been tested per time, defects per hour, defect removal leverage, that kind of stuff. These are, I'm going to go through, I think, fairly quickly, if I remember correctly. Some of these have good numbers for you to know. 5 defects per 1,000 lines of code in a unit test is good. 40 is typical. Those are good numbers to have. I should pull them out on a separate slide. Reviewing. If you can review rate, if you can do code review, 150 to 200 lines of code per hour is the maximum rate. So if someone says, hey, I want you to review this class and see if it's any good, or, you know, these two classes work together. So review this class, and you look, and it's you know, 300 lines of code in that class. That's a 2-hour review. It gives you an idea of what coverage in your review means. These are, I like these numbers. These are good to know. I should pull them out. Design time to review time, code to review time, design time to look at design time to code time 1-to-1, design review time to design time 1-to-1. In other words, if you're doing design for an hour and then you should review the design for an hour, that should produce 1 hour of coding time. Now, these numbers are put in by Dr. Oshoa based on his recent industry experience, so I think they're pretty good. I should say valid. Now, I'm sure that students don't have a 2-to-1 design and design review to coding time. Am I safe in assuming that that's true? Yeah, I think that's pretty true. And so when the coding is working well, that's not a problem. But when the coding is not working well, often when students come to me and say, man, I'm having trouble with this code, I can't figure out how to do this. Usually they don't have a coding issue, they have a design issue, usually. And it may be a design at the class level, if we're doing object-oriented stuff, or when they're in a method It may be a design at the algorithmic level. They're not sure what steps to take. But usually what happens there is it goes back to being a class level design issue because they don't have within that class the attributes they need to describe what they need to do the thing they're trying to do. So almost always when a student comes to me and says, oh, I can't figure out how I'm going to make this happen, it's almost always not a coding issue per se, it's a design issue. And hopefully they haven't gotten too far along their coding that they have to rip apart their design too much. You know, if they do, we try to find really bad, ugly workarounds, but you know, so they don't have to just tear up a bunch of code. Defect ratios, code review to compile 2:1, design review to unit test 2+1. If you have a good review, right? Code review. In other words, walking through the source code with somebody. Hopefully you guys in your teams, you're looking at each other's code informally and doing these informal reviews. You may actually have a formal review. You may sit down and say, look, I'd really like to have you guys go through this and see if it makes any sense as part of your, say, sprint review. Or offline in between your scrums or something like that. It improves the quality of the code, and remember what part of Scrum is: getting this osmotic communication. Yield, total day defects found and removed. You're hoping to get 76% of your defects found and removed before you first compile. Compile and test, I should say. Now, this is assuming a really formal structure where you have a requirement, design review, code review before you get into unit test. So this is not assuming the more informal kind of coding and testing that we have in this course, and that I suspect you see in most agile processes. So in order to get this 76% yield, they're assuming this pretty tail heavy process. Defects per total hour. Let's go through these. I don't care about this. I don't care about this. This I care about. Data review. You can find about almost 1 3/4 defects per hour in design. And you can find about 4.2 defects in the hour of coding. Excuse me. What that really means is there's less defects injected in the design. That's what that really means. So if you spend more time in design, you know, let's say you spend 10 hours in design, you're going to get 18 defects. As opposed to if you spent 10 hours in coding, you're going to get 42 defects. So the idea is if you could spend out of a 20-hour task, maybe 15 in design and 5 in coding, then the defect rate goes way down. Why? Because you're spending all that time getting a good design. And it's very difficult. I don't know how to enforce the development of a complete design, number one, but it's a good process. It's a good practice, number one. And number two, think about it in the Agile term. You don't want the whole design up front in Agile, do you? So let's adapt this to Agile. Now, this is assuming more, you know, PSP was really assuming more of a waterfall model where you had the whole design up front. But let's bring this to Agile. How can you talk about design in the Agile environment? How can you adapt this? Any thoughts? We'll go through the process. At the beginning of the sprint, aren't you assigned some software tasks? Typically. And what's your process to complete those tasks? What's your process within the sprint? Hope. You'll. How about this for a process? You receive a software task. Okay, I'm supposed to do these three. My job of this sprint is to get these three methods completed in this one class. I know you get more than that, but I'm supposed to get these three methods completed. I should look at the design of the class and the design of the overall product, and then plan out my methods. Now that would be an algorithmic thing at that point, right? I could write out my little algorithm in pseudocode for each of these methods, and I could verify before I started coding that this class has all the attributes that it needs, and it has access to attributes in other classes if needed. I could do all that before I started coding. And that way, if I needed to modify something in another, let's say I needed to modify another class. Oh, wait, in order to do this, I have to call, you know, subclass.foo. And I'm looking at, and I can say, man, even before I started coding these three methods, I realized I didn't have the data that I needed. I didn't have the interaction that I needed. Therefore, we need to modify this other class over here. And you can identify those design changes before you start coding. Throw it out to your team. Hey, I found that we need to do this stuff. You guys, you guys have 24 hours to give me the green light, or I'll assume a green light, right? 24 hours to respond, or I'll assume it's okay. And then you can start coding. As opposed to starting the coding and then halfway through, and we've all done this. Oh crap, I need this in this other class. I forgot to put it in there. Come on, we've all done it. All right, I'll go change it. Okay. That's a good way to introduce more errors. So instead, when you get your task, well, first of all, you've hopefully got a requirement, you've gotten test cases, and then you can look at your design and then code. If you do this, and I have experienced this, if you do this, the coding is much simpler. The actual coding should be the most boring part of solving the problem. You solve the problem ahead of time, and then the coding is just the implementation of that solution. And it should be fairly dull and fairly defect-free because you've caught these in the design. Okay. There's everything. Everything gets complicated. Everything has levels. So the PSP does have levels. At the 0, you're just basically measuring stuff. And the next level, you're doing your estimating. At the next level, you're doing real code reviews, and there are design templates which are not included in the package that I gave you. And then you get cyclic development, right? Again, notice how at the highest level, the process is a self-optimizing or a self-modifying process. Okay, now one more thing. In this slide, I didn't know where to put this slide. I inherited these from Dr. Ochoa, and I've reorganized them and added some stuff to them. And then he had this, which I didn't know where to put it. It's not related. It's not really related to PSP per se. I still think it's a good piece of work. And again, the whole thing is about experience. How are you going to estimate effort and size? Well, experience. I've done it before. Customer comes in and wants you to make some product. Oh yeah, I've done 3 of those in the past. Here's how long it'll take, probably. So here in the object-oriented world, you are determining the objects that's required to build the product. That's your initial design, your architectural high-level design. You're laying out your UML so you have a good feeling for the types of attributes and methods. And then you look back at historical data, experience. Now, instead of just gut feel experience, yeah, I've done this before, and this will take, you actually can keep track of how much effort it took to build previous projects and or products, and compare against their size. And people do metrics. How many classes were there? What was the average lines of executable code in each class? How many attributes per class? What was the largest? And then linear regression testing, which sounds fancy, but you know how you do that. You just put dots on a graph and make a line, right? That's the cheap way to do that. Now, it is unfair of us, and I need to fix this. I mean, I need to make a note to fix this. It is unfair of us to have you go through EGR 115 and CS 223 where you actually write code, and then CS 225 where you get lots of opportunities to write code, and then SE300, and then at the end of the semester say, oh, by the way, you should have been keeping track of all the sizes of lines of code that you wrote and the time it took throughout those last 2-3 courses, so that you'll know how to estimate better. Put that down. I gotta write that down. What we should do if we were being consistent as faculty is have you guys write up the estimates all the time. Not a lot, just here's how many lines of code, here's how many hours it took. Here's how many lines of code, here's the hours it took. And that way, by the time you get to SE300, you'd probably be much better at estimating your times. That's a guess. Is that a good idea? Bad idea? Doesn't affect you, right? It affects the people behind you in the curriculum. Yeah, so, and again, it's just it's simple logging, right? Now I do in CS 225, I have introduced for extra credit where students report their how many hours they spend on homeworks and project stuff. Because I want to, number one, I wanted to know if my estimates were right, and number two, I thought it would help them learn more how to estimate their own stuff. Yeah, every process can become, you get metadata on the process, right? Okay. All right, are there questions or issues or anything like that before we head out?
Hi, Professor. I came in like a second too late, so I only heard half of what you said at the beginning, but did you say that the next few weeks, the Monday class will just be office hours?
That is correct. This was the last module of lecture material, right?
Okay, thank you.
Yeah, and also there's let me get my team. A10 is going to meet at 4:30, and team 12 normally meets right after this meeting. If team 12 wants to wait till 5, I'll be in that meeting. If not, I'm going to go to the team 10 meeting. And the reason I'm picking 10 over 12 is because I've been in more team 12 meetings than team 10 meetings. So just to let y'all know. So team 12, it's your choice. If you want to start, right after the class, that's fine. If you want to wait till 5, then I'll be in the meeting with you. It's just a scrum, right? Okay. All right. Okay. Other than that, any other questions or issues or concerns or anything else? All right, guys. No more lectures, but I will see you. I'm back into attending meetings this week. I've gotten some of the Sprint 3 stuff graded and returned, and that's my focus for this week is Sprint 3 grading and meeting attending. Have a good one.